Welcome to All This Math. This is Professor Parker, and this video is for my young boy Amir. All right, Amir, what's up, man? Hope you're watching. All right, now today we're going to talk about this word problem right here. Let's read it first, because when we deal with word problems, we should read them. Because before we do math, we need to deal with our reading. We need to apply reading comprehension before we even start adding, subtracting, multiplying, or dividing anything. All right. So this says that Caden has 3 times as many dinosaurs as Leo. And Leo might be named after William Leo Hansberry. William Leo Hansberry was a history professor at Howard University in Washington, D.C. back in the 20th century. And actually, something interesting about William Leo Hansberry, who you should look up if you're not familiar with him and his work, he was actually the uncle of Lorraine Hansberry, who you might be more familiar with. Lorraine Hansberry is known for writing the classic theater, classic play, A Raisin in the Sun. So those are 2 people you should check out, right? So when I saw this word problem, I got a little excited because I said, oh, okay. The youngin in the word problem, his name is Leo, so he might be named after William Leo Hansberry. And if I talk about William Leo Hansberry, then I could talk about Lorraine Hansberry, right? All right. As I continue on, I also got more excited because I said, oh, Ella. There's somebody named Ella in this word problem. Now, Ella is an important name for me because Ella reminds me of Ella Baker. Maybe this young sister in the problem is named after Ella Baker. Ella Baker, who attended Shaw University in North Carolina, and also is probably most well known for, well, maybe for her work with the NAACP, but probably even more well known for her work in establishing the Student Nonviolent Coordinating Committee, which is also known as SNCC, SNCC, which helped to develop the scholar and humanitarian activists such as Kwame Ture, Marimba Ani early in her life, Bob Moses, the developer of the Algebra Project, Charles Cobb, Cleveland Sellers. The list goes on and on and on. So when I see the name Ella, I always think about Ella Baker. So those are 3 names I just dropped on y'all before we even got into the math, right? William Leo Hansberry, Lorraine Hansberry, and Ella Baker, right? 3 very influential people of African descent that we should all know about. All right, now let's get back into the problem. Now, Ella has 5 fewer toy dinosaurs than Caden. Altogether, they have 44 toy dinosaurs. How many toy dinosaurs does Ella have? All right, so it's 3 people. 3 people. We got Caden, we got Ella, and we got Leo. All right, Caden, Ella, and Leo. All right, we know how many dinosaurs they got all together, 44. But we want to find out how many Ella has. We don't know how many Ella has, but what we do know is that Ella has 5 fewer toy dinosaurs than Caden. Now, if I knew how many dinosaurs Caden had, then I could figure out how many Ella has, because 5 fewer then means just to subtract 5. Problem is, I don't know how many Caden has. I know that Caden has 3 times as many as Leo has, but still, I don't know how many Leo has. So this is a problem where we're going to use algebra. We're going to use algebra. All right? And we're going to create a chart. And a problem like this, where you got different names, different people, I like to create a chart. So check this out. I'm gonna make a chart, and in my first column of my chart, I'm gonna have the names of the 3 people. All right. So first I'm gonna have Kate, and then I'm gonna have Leo, and then I'm gonna have Ella. So those are my 3 people. Right. Now over here in this column, I need algebraic expressions to represent each of those people, right? Because math is a language, right? And if I can translate each of those names into an algebraic expression and then create an equation, then I can figure out the unknown variable, and then I'll be able to tell how many toy dinosaurs Ella had. And the thing about this is, like, if you can figure out and understand what I'm trying to explain now, whenever you see a problem like this, you'll know how to do it, right? It don't got to be about toy dinosaurs. It don't got to be about these 3 people. It could be about any people. Don't even have to really be about people, right? It could be about inanimate objects. But But this is a very important skill. So pay careful attention to what I'm about to show you. Now, when I do a problem like this, I need to create a variable, right? I don't want to have 3 different variables for each person. I need one variable. Now, the question you probably are going to have is, well, how do I know which variable to use? Or how do I know which person is going to represent the variable or be my variable? Now, there are many ways to do this, but the way I do these problems, the way that's most comfortable for me and the way I learned was I look at one of the sentences. I pick one of the sentences. Usually I pick the first sentence in the paragraph, right? So I'm going to pick this one. It says, Caden has 3 times as many dinosaurs as Leo. So I look in that sentence and I say, okay, well, how many people are talked about in that sentence? I say, oh, 2 people. 2 people get talked about. And I say, okay, who got talked about second? Who got talked about second? Caden got talked about first. Leo got talked about second. So whatever person gets talked about second, I let that person or that entity be my variable. So since Leo got talked about second, Leo's going to be my variable. Now, what variable do I use? I can use any letter I want. But since his name starts with L, remember we talked about William Leo Hansberry? His name starts with L. I'm going to use L. I'm going to use capital L. Boom. Now, how do I figure out how I'm going to represent Caden and how I'm going to represent Ella? I'm going to create expressions based on the information that I have in the rest of the problem. Now, if Leo is L, now we go back to the sentence. Now, again, that's why that's why I said it early on, reader comprehension is important for us to be able to answer these problems, right? Before we even start doing math. This says that Caden has 3 times as many dinosaurs as Leo. So 3 times, that's a mathematical phrase. 3 times. 3 times, that's not division. That's not addition. That's not subtraction. That's multiplication. So 3 times as many as Leo. So if Leo is represented by L, well, really what I mean to say is the number of dinosaurs Leo has is represented by L. If Caden has 3 times as many, then doesn't that mean 3 times L? That makes sense, right? If Leo's dinosaurs are represented by the letter L, and this says that Caden has 3 times as many dinosaurs as Leo, then wouldn't that mean that Caden is also 3 times L or 3L? Boom. So now I know what Caden is represented by. Now, I'm not going to be able to tell immediately how many toy dinosaurs Ella has, but I know what phrase or what expression I could use or what term I could use to represent how many toy dinosaurs she has. All I got to do is read this sentence. Ella has 5 fewer toy dinosaurs than Caden. 5 fewer. That's important. That's another little mathematical phrase. 5 fewer, right? Now, fewer doesn't mean that you're subtracting 5, right? You're going Ella minus Caden. You actually got to look at it backwards. See, we got to understand the conventions of the English language in order to work through word problems and break them down and make them manageable and then do the algebra. So if Ella has 5 fewer toy dinosaurs than Caden, what we're saying is however many Caden has, you just subtract 5 from that. So however many Caden has, you subtract 5 from that. Notice what I said. However many Caden has, which is 3L, or represented by 3L, you subtract 5 from that. Not the other way around. You don't do 5 minus 3L. That's a common error. That's a common error. In this type of problem, you would not do 5 minus 3L, right? Because we're not saying that Caden has 5 fewer than Ella. We're saying that Ella has 5 fewer than Caden. So however many Caden has, we subtract 5 from that. So this is how we represent that. Caden's toy dinosaurs minus 5. The minus 5 part is the 5 fewer part. The 3L part is the Caden's toy dinosaurs part. And now we got an expression for every person. All right. Now let's keep reading, because now I need to know how to set up my equation. Because now I got my individual expressions to represent each of the people and the number of dinosaurs they have, right? So now I need to keep reading so I can set up an equation. Because in an equation, I got an equal sign, and I got information on the left side, and then I got information on the right side, right? That's what I got in any equation. So it says all together. Now, whatever you see all together, that's a buzzword. All together is a buzzword. So you should underline that if you see that. All together means you're going to add everything up. It's all together. So you add everything up, right? They have 44 toy dinosaurs. So all together, after I add Caden's toy dinosaurs, Ella's toy dinosaurs, Leo's toy dinosaurs, all together, they're going to have 44. So the way I translate that into an equation, it looks like this. Caden's toy dinosaurs, 3L. Now, all together means add, right? It means addition. It don't mean multiplication. It don't mean subtraction. It don't mean division. It means addition. Then I got plus Leo's dinosaurs. That's just plain L. Plus Ella's dinosaurs. That's 3L minus 5. All right. Now, some people will say you should put parentheses around the 3L minus 5, and you can do that, but it really doesn't matter in this particular case. If we were subtracting Ella's toy dinosaurs, then it would definitely matter. It will make a huge difference. And I would have been sure to put parentheses around 3L minus 5. But because we're doing addition, the parentheses really are extraneous. They don't really matter. All right, now, all together, how many dinosaurs we got? 44. So that means that this plus this equals 44. All right? So now we set up our equation. So now we're going to do a little bit of algebra, right? First thing I'm going to do is I'm going to do what's called combining like terms. Combining like terms. So I'm going to look on the left side of this equation, right? The left side of the equal sign. Everything that's got an L in it, I'm going to combine them. So I can have a single amount of L's. One term with all the L's together. So I got 3 L's right here. Here goes 1 L. And there goes 3 more L's. Altogether, that's 7 L's. 3L plus 1L is 4L. 4L plus 3L is 7L. Boom. 7L. Minus 5. Bring that minus 5 down. Right there. Is equal to 44. 7L minus 5 equals 44. All right. Now, my ultimate goal is to solve for L. Because once I solve for L, I'll know how many toy dinosaurs Leo had. And once I know how many toy dinosaurs Leo had, then I can figure out how many toy dinosaurs Caden had. And once I figure out how many toy dinosaurs Caden had, I can just subtract 5, and I'll know how many toy dinosaurs Ella had. So it's a step-by-step process. We got to go through the steps, and we got to trust the process, right? So now, I'm trying to get L by itself. So in order to get L by itself in this equation on the left side, I got to get rid of 2 things. I got to get rid of this -5, and I got to get rid of this +7. I got to get rid of the -5, and I got to get rid of the +7. Now, you might be wondering, well, what do I get rid of first? I get rid of what's further away from the L. You see, this 7 is all up on the L's back, all up on his back, right? That's called a coefficient, right? So that's closer to the L. So I'm going to get rid of that last. I'm going to get rid of this -5. Now, how do I get rid of the -5 or the -5? I do the opposite operation. The opposite of subtracting 5 is adding 5. So I'm going to add 5. And with equations, we always want to be balanced. So if I add 5 on the left side of the equation, I also need to add 5 on the right side of the equation. So -5 plus 5 gives me 0. And that's what I wanted to happen. Because remember what I said, I'm trying to get rid of -5 so I can get L by itself eventually. Then on the right side, 44 plus 5 is 49. Then I bring the 7L down. Now I got to get rid of this 7. Because now my equation says 7L equals 49. Now I got to get rid of the 7. So again, we're always doing opposite operations. When we're solving equations, we're doing opposite operations. What's the opposite of multiplying 7 by something? The opposite of multiplying is dividing. So I'm going to divide by 7 on the left side. And again, in math and in equations, in algebra, we need balance. So if I divide by 7 on the left, I also need to divide by 7 on the right. What's 7 divided by 7? Well, anytime you divide anything by the same thing, you get 1. 7 divided by 7 is 1. And that's how we got rid of the 7, because the 7's turned into 1s. Well, the 7 turned into a 1 when I divided it by 7. So now I got 1L. 1L is the same thing as just L. That's how many L's you have. You got 1. So that's 1L. And then we have 49 divided by 7 over here. Now, if we know our multiplication facts, and we know that 7 times 7 equals 49, therefore, 49 divided by 7 equals 7. So that means that L equals 7, which means that Leo had 7 toy dinosaurs. Now, actually, I don't really care about how many dinosaurs Caden has. I said something earlier that I probably shouldn't have said, because I really don't need to know how many dinosaurs Caden had. I could jump right down here, because I know that if I know that L is 7, I can forget about Caden, and I can go straight down to Ella, because Ella's expression says 3 times L minus 5. So if I know the number for L, I could just replace the L with the 7 and then do the math, right? So I could use this expression. What's 3 times 7? Again, multiplication facts. 3 times 7 is 21. 21 minus 5 is 16. So that's how many dinosaurs that Ella had. That's how many dinosaurs that Ella had. All right. So Caden, now let's check our work. Let's make sure. So yeah, I am going to go back and figure out how many Caden had. So if Caden is represented by 3L and L is 7, then that means that 3 times 7 is going to be 21. All right. Now, so that means that Caden had 21 toy dinosaurs. Leo has 7 toy dinosaurs. Ella has 16 toy dinosaurs. And let's make sure this all makes sense. First of all, let's make sure that they all add up to 44, right? What's 21 plus 7? 21 plus 7 is 28. What's 28 plus 16? 28 plus 16 is going to be, 28 plus 10 is 38. 38 plus 6 is 44. 21, 7, and 16. That's definitely 44. Now, it says Caden has 3 times as many as Leo. Caden has 21. Leo has 7. 21 is 3 times 7. 3 times as many as 7. Ella had 5 fewer than Caden. So Ella has 16. Caden got 21. That's 5 fewer than Caden. We good money. All right. So I hope this was helpful. And this is like, just a good example of a word problem where we have multiple items, multiple people, multiple amounts, and we have to create expressions. This is the key right here. This right here, creating a table of information like this will make life so much simpler. This is about organizing your work and organizing your information. Once you can do this, then you go to the equation, set the equation up and solve it, right? But before you do this, you got to be able to read and understand, right? And analyze and be able to translate this from here into and out to algebraic expressions, right? Because math is like a language. Math is like a language. And we have to be able to translate it from the English language into mathematical language using expressions, terms, and, mathematical phrases. All right. So I hope this was helpful. Amir, I hope this is helpful to you. Let me know. Holla at me. All right. Everybody else, please like the video, share the video, tell some people about it. Subscribe to the All This Math page if you have not already. Tell a friend to tell a friend. And as I always say, do remember that there's all this math all around you. Peace.